In software engineering, extensibility is a system design principle where the implementation takes future growth into consideration. It is a systemic measure of the ability to extend a system and the level of effort required to implement the extension. Extensions can be through the addition of new functionality or through modification of existing functionality. The central theme is to provide for change typically enhancements while minimizing impact to existing system functions. Extensibility is a software design principle defined as a system unregistered trademark's ability to have new functionality extended, in which the system unregistered trademark's internal structure and data flow are minimally or not affected, particularly that recompiling or changing the original source code is unnecessary when changing a system unregistered trademark's behavior either by the creator or other programmers. Because software systems are long-lived and will be modified for new features and added functionalities demanded by users, extensibility enables developers to expand or add to the software unregistered trademark's capabilities and facilitates systematic reuse. Some of its approaches include facilities for allowing users unregistered trademark-owned program routines to be inserted and the abilities to define new data types as well as to define new formatting markup tags. Extensible design. Extensible design in software engineering is to accept that not everything can be designed in advance. Light software framework which allows for changes is provided instead. Small commands are made to prevent from losing the element of extensibility, following the principle of separating work elements into comprehensible units, in order to avoid traditional software development issues including high cohesion and low coupling and allow for continued development. Embracing change is essential to the extensible design, in which additions will be continual. Each chunk of the system will be workable with any changes, and the idea of change through addition is the center of the whole system design. Extensible design supports frequent reprioritization and allows functionality to be implemented in small steps upon request, which are the principles advocated by the agile methodologies and iterative development. Extensibility imposes fewer and cleaner dependencies during development, as well as reduced coupling and more cohesive abstractions, plus well-defined interfaces. Importance. Fickleness lies at the basis of all software because of human phenomenon since software is an evolving entity which is developed and maintained by human beings, yielding ongoing system changes in software specification and implementation. Components of a software are often developed and deployed by unrelated parties independently. Adaptable software components are necessary since components from external vendors are unlikely to fit into a specific deployment scenario off the rack, taking third-party users other than the manufacturer into consideration. Many software systems and software product lines are derived from a base system, which share a common architecture or sometimes large parts of the functionality and implementation but are possibly equipped with different components that require an extensible base system. Classification of extensibility mechanisms. There are three different forms of software extensibility: white box extensibility, gray box extensibility, and black box extensibility, which are based on what artifacts and the way they are changed. White box extensibility. Under this form of extensibility, a software system can be extended by modifying the source code, and it is the most flexible and the least restrictive form. There are two sub-forms of extensibility, open box extensibility and glass box extensibility, depending on how changes are applied. Open box extensibility, changes are performed invasively in open box extensible systems. That is, original source code is directly being hacked into. It requires available source code and the modification permitted source code license. Open box extensibility is most relevant to bug fixing, internal code refactoring, or production of next version of a software product. Glass box extensibility. Glass box extensibility allows a software system to be extended with available source code, but may not allow the code to be modified. Extensions have to be separated from the original system in a way that the original system is not affected. One example of this form of extensibility is object-oriented application frameworks which achieve extensibility typically by using inheritance and dynamic binding. Black box extensibility, as opposed to white box extensibility. Black box extensibility refers to the way in which no internal details about a system unregistered trademark S implementation or any form of source code is available for implementing deployments or extensions. Only interface specification would be provided. This type of approaches is more limited than white box approaches. Black box extensions are typically achieved through system configuration applications or the use of application-specific scripting languages by defining components interfaces. Gray box extensibility. Gray box extensibility is a compromise between a pure white box and a pure black box approach, which does not rely fully on the exposure of source code. Programmers could be given the system unregistered trademark S specialization interface, which lists all available abstractions for refinement and specifications on how extensions should be developed. Extensibility versus reusability. Extensibility and reusability have many emphasized properties in common, including low coupling, modularity and high cohesion. Software reusability is boosted by extensibility and refers to software elements unregistered trademark ability to construct for many different software systems, which is motivated by the observation of software systems often sharing common elements. Reusability together with extensibility allows a technology to be transferred to another project with less development and maintenance time, as well as enhanced reliability and consistency. See also, Scalability, Extensibility Pattern, Extensible Programming, XML, References, Johansson, Nicholas, and Anton La Paragraph FGREN. Designing for Extensibility, an action research study of maximizing extensibility by means of design principles. NPNP, ND. University of Gothenburg Department of Applied Information Technology, May 29, 2009. Web April 26, 2014. https GPIR-207771/GPIR 2077 20561 1 PDF. Rouse, Margaret. Extensible. Search SAO. NP, March 2007. Web April 27, 2014. http Target Come Extensible. Kelly, Alon. The Philosophy of Extensible Software. ACCU Professionalism in Programming, Web April 27, 2014. http ACUORG Journals/391. Zenger, Matthias. 1.2 Characteristics of Extensibility Mechanisms. Programming Language Abstractions for Extensible Software Components. Lausanne, Swiss Federal Institute of Technology, 2004. NPAG. Web April 26, 2014. http Zenger Urge Thesis PDF. Zenger, Matthias. 1.3 Clasher-Cation of Extensibility Mechanisms. Programming Language Abstractions for Extensible Software Components. Lausanne, Swiss Federal Institute of Technology, 2004. NPAG. Web April 26, 2014. Zenger, Matthias. 1.1.1 Reusability. Programming Language Abstractions for Extensible Software Components. Lausanne, Swiss Federal Institute of Technology, 2004. NPAG. Web April 26, 2014.